Okay, Assalamualaikum warahmatullahi wabarakatuh. Okay, today we will continue on chapter 5 on phase equilibria. Okay, the content on phase equilibria, you're going to learn about phase, component, phase rule, degree of freedom, and then we're going to cover on one component system and also two component system and colligative properties. Okay, and then the learning outcome, okay, by the end of the lesson, by the end of the lesson, you should be able to identify the phase and component. You could explain water and CO2 phase diagram. You could explain the root law, which is applicable on ideal and deviation phase, and then also you're able to draw vapor pressure composition and boiling point composition phase diagram, solve the quantitative problem related to P, TB, and also TF, and explain what is qualitative properties. Alright, so we go first with phase. Phase, all of you already know the meaning of phase, meaning that it are in the same system. Okay, for example, homogeneous region, they are in the same matter. Alright, so they are in one system, we call it as phase. Alright, so a phase can be defined as distinct homogeneous part of that is separated from other part by distinguished boundary. So it can exist as solid, liquid, or gas. Okay, and then furthermore, it can also coexist as combination of two phase or three phase at once. Okay, that's why in phase equilibrium we're gonna learn about this one. All right, so gas or gas mixture, they are in single phase. Okay, they are considered as one phase. Miscible liquid that's mixed together, okay, they also are in single phase. Mixture that immiscible liquid, immiscible means do not merge to each other, it cannot mix together, so that's why it has two phase. Okay, at least two phase. Immiscible liquid is an element with two allotropes and mixture of two different state of substance. Okay, substance normally must be exist in three different states, such as solid, liquid, or gas, that form three phase of system. Number two, you must know about component. Okay, phase is being denoted by P, component is by C. So component describe different substance required in all phase system. Okay, for example, ice and water, they are coming from one component because there are H2O. Though this is in different phase, this is ice, okay, in solid, water in liquid, but in component they are coming from one type of category, okay, which is H2O. So they are in one component. Water and ethanol, this is clearly different thing. Water is H2O, ethanol is different thing, alcohol. Alright, so there are two components. But water and CCl4, right, also two components here. Then we look at this one. This is an example of the system, example of the phase, example of number of phase, and also component. Okay, for example, air. Air consists of any gas, oxygen, CO2, and nitrogen. There are gas. There are one gas. Okay, there in the phase there are gas, type of gas, but in number of component there are many. There are different type of gas. Ice and water. This is solid liquid phase. Number of phase is 2. Number of component is 1 because they are coming from H2O. Okay, water and liquid. One is water and vapor. One is liquid, one is gas. So this is two phase but one component. Both are H2O, vapor. H2O could be vapor. Right, ice and vapor, solid and gas. This is still two phase but one component. Ice, water and vapor also one component but three phase. Okay, look at the other example. This is miscible liquid, sorry, water and ethanol. Water and ethanol, they can mix together because both consist of OH. Alright, so they can mix together. So this one, number of phase is considered as 1. Okay, they are homogeneous, but number of component is 2. Water and CCl4. Water and CCl4, this is immiscible liquid. This is type of liquid, so two phase but two component as well. Iodine, crystal and vapor. Okay, name are the same. Okay, might be component, yes, is one, but shape or phase are different. One is crystal, Okay, in type of solid, one is in vapor, so two phases. Alright, rhombic sulfur and monoclinic sulfur. Component is one because they are coming from one component of sulfur. Alright, but phase is two. One is in rhombic, one is monoclinic. Okay. Right, so next is freedom, degree of freedom, or denoted by F. Okay, degree of freedom is how many number of intensive variable that can be independently varied without changing the phase of the system. Alright, so this is it has effect on intensive variables such as temperature, pressure, concentration on the phase or equilibrium phase as well. Okay, so let's see formula first for phase rule. For phase rule, we use this formula. Degree of freedom F is equal to C component minus P phase plus 2. This is always the formula, so just take it as it is. Alright. Okay, so let's say, yes, P is number of phase. Number 2 is intensive variable between temperature and pressure. Okay, so alright, so look at an example here. Okay, so okay, escape this one. Okay, look at this example. This is much more clear. How many components do we have here? Alright, so we want to know the C. Okay, how many components? Should be how many degree of freedom. Alright, so this is one component which is contained of H2O, but it has different phase. It has vapor, it has solid, and also liquid. Right? Okay, so in here we want to see region of A and B. A is here, B is here. So they are in this region. So now, let's say on this region, we use the formula freedom is equal to component minus phase plus 2. So how many components that we have in here, in this region? This is only water, H2O. So it's only one component. Phase, they are still in one phase. Okay, they are still in one phase of the same one, vapor. Alright, so we consider as 1 plus 2. So 1 minus 1 is 0 plus 2 is equal to 2 degree of freedom. How about if the question asks you to find the number of freedom here, degree of freedom at the point here on the line, okay, on the phase line. Alright, so we use the formula freedom is equal to C minus F plus 2. So number of components still 1. They are still coming from 1 H2O. Number of phase, at this point we have 2 equilibrium phase between liquid and vapor because it's seated right on the boundary here. Alright, so that means the P is 2 and then you plus 2 is equal to 1 degree of freedom. Okay, how about at triple point? Triple point is where the point of the liquid, solid and vapor or gas is at the same point, which is at here. Alright, so at triple point we can see here component still 1 because this is coming from H2O. Phase here is 3 phase involved because we have vapor, we have liquid, and then we have solid at equilibrium here. Okay, so that's why 1 minus 3 plus 2 is equal to 0 degree of freedom.